Hey guys. All right, this is your video that I promised. Okay, so what we're going to be talking about today is something called measures of variation. All right, so you have measures of center. So we went over that, mean, median, mode, and mid-range. Or we're going to go over measures of variation. Now, if everything goes according to plan, I'm going to share a PowerPoint with you and just kind of talk you through it. And then your homework will be on Moodle where it always is, just in its regular location up at the top, okay, of the page. This video will be down on, this video is down under the week, but the homework's in the regular page. All right, let me give you kind of a scenario. Suppose I told you that I was afraid to fly. It's not true, but let's just pretend, okay? And so I had to get on an airplane, so I was really nervous. So I had two choices. I could get on plane 1 or plane 2. So I went back and dug and looked at some research to try to figure out how safe they were. So I started looking and trying to figure out, when do they have engine trouble? Okay. And what I found out was, so I went back and looked, and both of them had engine trouble at around 1,089 flying hours. Okay. So now how would we get that? All right. So remember how you get mean. You add your data and then divide by how many you have. So suppose I went and looked at plane 1, and at 1,005 hours, there was an engine situation. And then another time on that same kind of plane, it was 1,116 hours before they had engine trouble. And then another time, this same kind of plane had trouble at 981 hours. Another one with the same engine had trouble at 1,067 and 1,044 and so forth. Now, how would I get the mean? What would I do with all of these numbers? All right. We're clear that I would add them all up and then divide by how many there were, and I got 1,089. So this kind of plane usually has engine trouble at around 1,089 hours. That's the measure of center. All right. That's the average when they had engine trouble. Well, suppose I've got a choice about plane 2, and I look at it and I say, oh my goodness, the first time it had trouble was almost 1,900 hours. And I'm thinking, yeah. And then I look, oh my goodness, at 2011, like the right engine blew out. That's not good. It's fine till 1,012 on this plane. Another plane just like this lasted till 1,755. Another one had a major malfunction at 363 hours. So again, if I added all this data and all these down here, I would get 1,089. So if I just look at the means, it looks like these two planes are basically the same, but they're not. See, if I dig deeper and look at how the data varies, and suppose I find out that I can either get on airplane 1 or airplane 2, and both of them have about 500 hours of flying time, which one am I going to get on? All right, do you see that airplane 1, these numbers kind of hover around the measure of center, so they're more densely located. But if I look at plane number 2, this data varies wildly. I mean, one time it was almost 2,000 hours before it had trouble. One time that was barely over 200 hours. So this data, plane 2, the data varies more than the plane 1 does. So that's why this measures of variation is important, because sometimes measures of center is not going to be enough to give you an accurate picture of the situation. So measures of variation mean how much does the data vary? Okay, how far is it spread? All right. So there are different ways to do that. All right. So we're going to talk about some of them. And the first one's going to be your favorite. All right. And that's range. Now look at how you get range. Range is just your biggest number minus your smallest number, just your high minus your low. So if I had some data over here, suppose this is my data, just small number of pieces of data. And I said, what's the range of that data? Well, the largest number in that list is 9, so that's my high. And the smallest number in that list is 5, and that's my low, and 9 minus 5 is 4. So the range on this data, this example, would just be 4. Now, that's going to be your favorite because it's so simple, but yet people miss it because it's really close to something we've gone over before. So close enough to be dangerous. So think about a word that had range as part of the word that we've already gone over. Right, do you remember doing mid-range last time? How did you find the mid-range? Didn't you also use your high and your low? But what did you do with your high and your low to get mid-range? Didn't you add them and divide by 2? Well, this time I don't add them, I subtract them. And the last time I divided by 2, and this time I don't divide. So they're close enough to be dangerous. All right. So with mid-range, I want you to think more like midpoint. You add 2 numbers, the low and the high, and divide by 2. But with range, you just subtract the high and the low and stop. Okay. So don't miss such a simple problem on your first test because you didn't take time to kind of get those distinctions kind of cemented in your mind. So mid-range is high minus low, end of story, done. So naturally, we don't use it a whole lot. All right, the one that we're going to use more, the one that you see used more outside in the real world is standard deviation. Now, standard deviation, this is not exactly what it is, but it's sort of the average distance of your data from your mean. So, you know, you got your mean, that's your measure of center, and then all your data is, you know, away from that mean. So it's kind of like your average distance. All right. Now there's going to be 2 symbols that stand for standard deviation. You got to distinguish between them. One is sigma. Now that's a lowercase sigma. You know how in English you have capital letters and lowercase letters, like capital A and lowercase a? You have the same thing in Greek. Now, we've already talked about this symbol. Let me get it. All right, so this is a capital sigma. This is a lowercase. Okay, so this means the standard deviation of a population, and a lowercase s means the standard deviation of a sample. Now, what you kind of need to notice, most of the time when it's a population symbol, they're going to use a Greek letter. Remember mu for mean. And most of the time, they're going to use an English letter for the sample symbol. So see, Greek letter of sigma for population, English letter of S for sample. Just like with mean, you had a Greek letter of mu for the mean of a standard, for the mean of a population. You had X with a bar over it for the mean of a sample. So I expect you know I must have used a sample. When you see sigma, when you're reading research, you know they use the whole population. So it's really important that you know the difference in these 2. They both stand for standard deviation, but it's where the standard deviation comes from. So which one do you think you're going to see more during the semester, sigma or S? Yeah, you're going to see S more often because we tend to use samples way more often than we use populations. Now, how do you find the standard deviation? I'm going to show you kind of 3 different ways to do it. And I'm going to let you pick. I know which one you're going to pick, but I'm going to let you do it. Now, the reason I'm showing this first way is this first way kind of shows you what it is. Okay. Now, your table is going to have 3 columns: X, X minus X bar, and then X minus X bar squared. Okay. So remember what I told you, X, the whole semester is going to stand for your data. So I just took my data up here and wrote it in this column. Now, I'm a little OCD, so I like to put mine in order. You don't have to. Okay. So this is my data. Now look what this column says. My data minus my, remember what X bar stands for, the mean of a sample. So I'm going to have to go over here to the side and find the mean of this data. Now remember, how do you find mean? Remember what you would do with all these numbers. You would take all of these numbers and you would add them up, and that's where I got the 34. So 8 plus 5 plus 6 plus 9 plus another 6 is 34. And then remember, you divide by how many pieces of data. So 1, 2, 3, 4, 5. So when I take that total of 34 and divide it by 5, I got 6 1/8. So the mean average for this number, the measure of center, is about 6 1/8. So what I'm going to do is I'm going to take every one of these numbers and I'm going to subtract that 6 1/8. So 5 minus 6 1/8 gave me a negative 1.8. 6 minus 6 1/8 gave me a negative 8/10. So I got another negative 8/10. Well, 8 minus 6 1/8 gave me a positive 1 2/10. And 9 minus 6 1/8 gives me a positive 2 2/10. So this is just your data. You had to go over here and figure out your mean and then just subtract your mean from each piece of data and write it down. So do you understand that saying that this 5 is below average 1 8/10? This 9 is above average 2 2/10. So if it's positive, that means that your number's above average right there. If it's negative, it's below average. But notice I couldn't just add these up and divide, because that would be misleading, because some of these negative numbers would kind of cancel out some of these positive numbers. So there were different ways to handle that. All right, one way would have been to use absolute value, but that's not the way they chose, and there's a reason for that. Okay, but another way to get rid of negatives, you know, is to square things. When you square something, it's no longer negative. But now when you square something, it changes it. So it creates another problem. But think about it. If I square the numbers now, how am I going to undo that later? Later, I'm going to end up taking a square root. Okay. But what I did was I took my calculator, I took a negative 1 8/10 times a negative 1 8/10. So when you square a negative 1 8/10, you get 3 decimal 24, 3 2400ths. Now, make sure on your calculators, that's not a minus, that's a negative key. And those are two different keys on your machine. All right. So that negative key is at the very bottom. It's a gray key at the very bottom of your calculator. Okay. So I took all of these numbers and squared them. I multiplied every number by itself, and look, all those answers came out to be positive. Now, the only time it wouldn't come out to be positive, if I was squaring 0, it would stay 0, but you're never going to get negatives. Then what did I do with this column? I just totaled it. I added this column up and got 10 8/10. Now, you would think that I was going to divide by the number of pieces of data, but instead of dividing by n, the formula is going to have you divide by n minus 1 total. My O didn't come out very well. And that's really helps you generalize a little bit better because you're using a sample. Okay, so I just counted, there were 5 numbers in my list. So remember, the whole semester, X is your data and N is your total, like your number of pieces of data. All right, so 10 8/10 divided by 4 gave me 2 7/10. Remember what we did? Because we squared, your last step is to take the square root of that. So my standard deviation is about 1 6/10. So what is that saying? That's saying that every piece of data is an average, is about 1 6/10 away from this center number. Okay, now in your book, the formula looks like this. All this formula is what I just did up here in simple. So look what this says. Remember, your first thing you do in order of operations is parenthesis. So it says you've got to take every number and subtract the mean. So see, you'd have to go find the mean. You wouldn't have to remember, you'd have to go find it. So then it says take every piece of data and subtract the mean. So that's what I did in this column. Then remember, what do you do after parentheses? Don't you do exponents? So then I would have to square them. So that's what I did. After I subtracted and got these answers, I squared all of them. Then look what it says. What do you do with all of these answers? Remember, that's a summation symbol which says add those answers. So that's what I did. I added those answers and got 10 8/10. So do you understand that this 10 8/10 right here is this 10 8/10 right here? Then it says, okay, divide that answer by n minus 1. So n's my number of pieces. So I counted and I got 5 pieces, and 5 minus 1 is 4. So when you divide 10.8 by 4, you're going to get this 2.7. And the square root of that 2.7 is about 1 6/10. I just rounded to the tenths column because my original data were whole numbers. Okay, so that's the formula. In your book, that's your very first formula for standard deviation. I just kind of did it in a table form so that you could follow my steps. So take every piece of data and subtract the mean, and then square all those answers and add them up, and then divide by your number of pieces minus 1. And when you get that answer, your last step is to take the square root of that answer. So that's one way to get standard deviation. All right. Now I'm going to show you another formula because there's another formula in your book. Now, why would you want another formula? Do you see that if this list had like 50 numbers, this would really be a long problem. If I had to get 50 different subtraction answers and square them all, okay? So the next slide is going to have a different formula that you can use if you want to, all right? And that formula says your favorite word in the book, shortcut formula, all right? Now look what this one looks like. That looks like this. So it's an alternative standard deviation formula. It looks like this. Now look what it says. Remember what X stands for. X stands for your data. Now I want you to notice something about this formula. This parenthesis looks a lot like this one over here. The only difference is where the 2 is. The 2 is inside the parenthesis over here, and the 2 is outside the parenthesis over here. But that changes everything because of my order of operations. So I do parenthesis first, okay? So I go in this parenthesis and there's 2 things in there. There's an exponent and an add. So think about your order of operations. What do you do first, exponents or addition? Don't you do exponents first? So that says square every number. So I went over here and squared 8, that would be 64. If I squared 5, that'd give me 25. If I squared 6, I'd get 36, plus 81, plus 36. So I squared the numbers and then added those answers up and got 242. So that's why the answer to this parenthesis is just 242. Because on this one, you square and then you add. Now remember what N stands for. N stands for your number of pieces of data. So 1, 2, 3, 4, 5. So that's why that N turned into 5. Now look at this parenthesis. When I go in this parenthesis, there's only one thing. It just says add the data. So it doesn't say square, it just says add the data. So if I said 8 plus 5 plus 6 plus 9 plus 6, I'd get 34. But that 2 is outside the parenthesis. So notice what happens here. I squared first and added second. Here I added first and squared second. So it matters which one you do first. Square first, add second, add first, square second. So you got to follow your order of operations. Also notice this N is only multiplied by the first parenthesis, not by the second parenthesis. Okay, little things like that will trip you up. So 5 times 242 is where I got 1210. I squared 34 and got 1,156. I've got to do this parenthesis first. So 5 minus 1 is just 4. So I've got 5 times 4 on the bottom. So 5 times 4 on the bottom is 20. When I subtracted these numerators, I got 54. And sure enough, 54 divided by 20 was 2 7/10. And the square root of 2 7/10, if you round to the tenths, is about 1 6/10. So I got the same answer with this formula that I got with the other formula back on this other slide right here. You can stop and back it up if you want to. Okay. Now, what's the advantage to this formula as opposed to the formula back on this slide? Well, let me show you something. All right, here's one advantage. All right, go back. Do you see on this formula, you had to have the mean to use this formula? So if you make a mistake finding the mean, you're going to have a mistake in your standard deviation problem, so you're going to miss it too. Whereas on this formula, I don't have to find the mean. So if I don't have to find the mean, that's one less mistake I might make. The other thing is with a longer list, this formula is just quicker. Okay, but you can use this formula or the other formula. Now, here's the third way you can find standard deviation, and that's going to be your favorite. All right, and it's going to be that you basically, let me clear this. All right, you can use your calculator. All right, your calculator will find the standard deviation for you with no work. Now, here's what I want you to do. I want you to pause the video and I want you to copy all these steps in your notes. Now, you should be pausing the video and copying down the steps all the time. All right, so you should have paused the video and copied down this first example over here. All right, if you didn't, go back and do it. Like rewind and copy down this example, and then rewind, stop it, copy down this example. All right, so I want you to stop the video and I want you to copy these steps down. And the reason I want you to do that is because I'm going to have to go over and do the calculator with you with a slide. So you need these steps next to you when I'm going over how to do it on the calculator. All right, otherwise I'll kind of lose you. So stop the video, copy these in your notes, and then come back. All right, here we go. Now, what we're going to do next, look what it says. All right. In your notes, you've gotten, there's a stat key. All right, so let's make sure we're good with that. All right, so I'm going to come right here and look at the calculator. All right. This stat key's right there. All right. So I've got a stat key right there. All right. Now let me get something real fast. Okay. Okay. All right. I'm getting my steps so I can kind of read through them as I go through them with you. All right. So look what it says. You got them on your thing. It says use the stat key. So there's your stat key. So you're going to press it. All right. When you press it, this is what should come up on your screen. Edit. Calc stands for calculate. T stands for tests. We're going to use all those buttons this semester. All right. I want you to hit edit. So if one of these is highlighted, you're going to use these arrow buttons if you need to make sure that edit is highlighted. And then you're going to hit enter in that bottom right corner of your calculator. Now, sometimes when you hit enter, there's already going to be a list of numbers right here. If there's a list of old numbers that you need to clear, then what you would do is you would take your arrow buttons again and you would move the cursor so it's highlighting this list number. And then when you highlight it, so what you would do is you would up arrow until you got right there, and then you would hit this clear button right here. Now, it gives you a chance in case you make a mistake. When you hit the clear button, it's not going to clear it immediately. You're going to have to then hit the enter button. It gives you a chance to change your mind so you don't accidentally wipe a list out. So if there's already a list of numbers, then what you're going to need to do is you're going to need to use these arrows, get over that list name, and then hit clear, and then come down here and hit enter, and it'll clear it out like I did over here. See, it wipes out all the data. Then what you will do next is you're going to type in every number. So I typed in an 8 and then I hit enter. And then I typed in a 5 and then I hit enter. And I typed in a 6 and I hit enter. So after every number, you type it in and then you hit enter until you have all the numbers in your list. Okay? So make sure that you get all your data entered. So that's how you enter data in a list. So let's review. You're going to go to stats and this screen's going to come up, and make sure you're on edit and then hit enter. And then if you need to clear the list out, take the arrows and highlight this and then hit clear and enter. Then enter your data like 8, enter, 5, enter until all your data is entered in your calculator. So anytime the whole semester we're entering data in the calculator, that's how you're going to do it. Okay. Now, how do I get it to give me the standard deviation? Well, here's what I do next. After my data is all entered, all right, let me go back for a second. After the data is all entered, you're going to go back. When this data is all entered, you're going to go back and you're going to hit that stat button right there again. Okay. So you're going to hit that stat button again, and this same screen is going to pop up like it did last time. But this time I want the calculator to calculate. So I'm going to use these arrow keys and I'm going to right arrow until calculate is highlighted. Okay, so these arrow keys are what makes it go up, down, up, down, or left, right with the cursor. These are your cursor keys. So you right arrow till it says calc. All right. And when it says calc, then what's going to happen next is on the machine, all of a sudden, it's going to be a blinking cursor and it's waiting for you to tell it what list to use, okay? So let me show you on the calculator. All right. So what happens is, do you see that mine are yellow? My second key is yellow. Yours might be a different number. Do you see how there's yellow things over the buttons? So if you want the yellow thing, you've got to hit the yellow key first. So I put my data in list 1. So on my calculator a minute ago, it said 1 variable stats. That's what I want to use, is 1 variable stats. All right. So under calc, I just chose 1 variable statistics. That's your first option. And I hit enter. And when I did, the cursor was blinking and I put mine in list 1. So I hit second and I hit 1 because L1 is in yellow. So second and 1 makes it calculate list 1 and then hit enter. And this is what comes up on my screen. Now look what I've got to do. I've just got to choose what I want. Remember, my standard deviation symbol was this S. So I'm picking this one because I used a sample. So again, I get about 1.6. Don't pick this one. That's the population symbol. Now notice, it'll also calculate your mean. So the calculator will calculate your mean too. Isn't that nice? So you can go back and homework for last time and use the calculator to get the mean and see if you get the same answer. You just enter your data in a list. You go to stat, you go over to calc, make sure you're on one variable statistics and hit enter and tell it what list to look in. Okay. Now, unfortunately, I didn't do the machine. I wish it just said S and sigma because that's the symbols. This SX and sigma X is a Texas Instruments notation. Don't put it on a test. I just want to say S is about 1 6/10. So you've got 3 ways to get standard deviation for me. All right. You can do it the first way, but you're going to have to memorize that formula. Or you can do it the second way and memorize that formula, or you can make the calculator do it. But if you're going to make the calculator do it, you've got to memorize these steps. Now you try it. If you have trouble, you send me a message and we'll Zoom one-on-one and make sure that you can figure it out. But I think if you've got the steps written down, you'll be okay. Okay. So that's how you find standard deviation with your calculator. And I said, notice the calculator will also do mean, and be sure to choose the standard deviation of a sample, not the population. So choose that S, not that sigma. Okay. Now, there's something else called variance. So you got range, just high minus low. You've got standard deviation. You can let the calculator do it. Then you've got variance. With variance, that's just a standard deviation squared. So notice, if you miss your standard deviation, you're going to miss your variance. Okay. So remember, we got 1 6/10 for our variance. If I square that, I get about that number. Some disciplines like education and science tend to like standard deviation. Some other disciplines like business tend to like variance. But do you see, if you know one, you always know the other? If you know standard deviation, you just square that answer to get variance. If you know variance, you take the square root to get standard deviation. So there are 3 measures of variation that you got to do on your first test: range, standard deviation, and variance. Make sure you can do all of those. Now, the other thing your book does talk about is something called a range rule of thumb. That's just a really crude, quick way to get an estimate if you don't have time to get the real standard deviation. So it's not great, but sometimes you don't have your calculator and you really need just a rough estimate. And to get a rough estimate of standard deviation using the range rule of thumb, you take your range and divide by 4. So remember a minute ago on that first slide, that second slide, our range was our high minus our low was 4. So if we took our 4 and divided by 4, we'd get a rough estimate of about 1 for our standard deviation. Remember, this was our real standard deviation. So they're not terribly, I mean, they're pretty far apart, but not awful, I guess. But the only time you're going to use that range rule of thumb is if you can't get the real standard deviation. Now, other thing on your first test you've got to be able to do is you've got to memorize percentages for me off of a normal curve, that bell-shaped curve we talked about in class the other day. Okay. Now, all data is not normally distributed. Okay, so let's make sure we're clear about that. All data is not normally distributed. I do not think the ages of MC students are normally distributed, but more data than you think is probably normally distributed, okay? So remember when you were doing measures of center and you do like the mean and the median and the mid-range, you wouldn't get the same answer for all of them? Well, one thing that's true about the normal curve is mean, median, and mid-range are the same number. Exactly. If your data is normally distributed. So that's one really important factor. Now remember, the median is the number physically in the middle of your list. So notice, physically in the middle of this curve would be right about here. But the symbol I've got down there, that's not the symbol for median, that's a symbol for mean. But the way I can put mean there is because on a normal curve, the mean and the median are exactly the same number. So on a normal curve, the median's in the dead center. If you take your mean and you add one standard deviation, and you take your mean and you subtract one standard deviation, if your data is normally distributed, 68% of your data is going to fall between this number and this number. Instead of adding one standard deviation, if you add two standard deviations, like if you went from here, and then you went and subtracted two standard deviations from there, 95% of your data is going to fall between this number and this number. And then if you do it for three standard deviations, like 3 deviations below to 3 above, 99.7% of your data is going to fall there. Now, let me give you an example with a real life example. The average IQ score is 100. Now, how do they know that? Because they've given millions and millions of IQ tests, and they've added all those scores up and divided by like 1 million that they gave. So they got mean the same way that you got mean. The standard deviation for IQ scores is 15. Now, where did they get the 15? The same way we got it in one of those slides. Okay. Now, look what it says. IQ scores, we found out, are normally distributed. So if the average is 100, so if I add one of my standard deviations, 100 plus 15 is 115. If I subtract one, 100 minus 15 is 85. What percent of people have an IQ between 85 and 115? 68% of the general population. Now, not 68% of the people watching this video, because you're not a random selection of the general population, okay? Now, what about if you add two of these? See, if I said 2 times the 15, that would be 30 plus 100 would be an IQ of 130. If I took that 100 and I subtracted 2 times 15, I'd be down to 70. So what percent of people have an IQ between 70 and 130? 95% of people have an IQ between those two numbers. And again, if you added 3 of the 15s, that'd be adding a 45. So you'd be up to an IQ of 145, and you'd be down to an IQ of 55 if you subtracted it. So 99.7%, almost all people have an IQ between 55 and 145. Now, lots of other things follow a normal curve besides IQ scores. So I do want you to understand the last third of the semester, we're going to deal almost exclusively with this normal curve picture, okay? Like women's weights follow a normal curve, but I guarantee you the average weight of a woman is not 100 pounds. The last time I double checked, I believe, seems like it was 143. And then if I remember right, the standard deviation was 29. So what that would mean is if I took the 143 and I added 29, I'd be up to a weight of like 172. And instead, if I took the 143 and I subtracted the 29, I'd be down to a weight of 114. So 68% of the general population of women weigh between 114 and 172. So the point I want to make here is this. If your data is normally distributed, these percentages will not change. Now these numbers will. because the mean and standard deviation for women's weights or men's heights is not the same as these numbers for IQ scores. So look what they could ask me. What percent of the general population, I guess it should say, has an IQ between 100 and 115? Well, now here's the other thing about this graph, it's symmetric. So that means that this half is a mirror image of this half. So if 68% are between here and here, do you understand that would mean that 34% would be over here? And then another 34 would be over here. Because 34 plus 34 gives me the whole 68. So what percent of people have an IQ between 100 and 115? Well, that'd be 34%. Well, what if they said, what percent of people have an IQ above 130? How would I answer that question? Well, now remember, 130, so I'm asking what percent are over here? What percent are over here? Now, I want you to notice something. 130, from 130 down to 70, that's 95%. So from there to there would be 95%. So that would leave me these people over here and these people over here. So how much is left to work with? If I say 100% minus 95%, that just gives me 5% left. And part has to go up here and part has to go down there. And because it's symmetric, they've got to be the same. So if I divide that by 2, that means that that area right there would be about 2 5/10%, like 2.5%. Okay. And that area right there would be about another 2.5%. Okay. So that would be 95% between the 2, and then 2.5 up here and 2.5 down there makes 100%. So one of the things you've got to be able to do for your first test is you've got to know these percentages. Okay. Now, think about it. If you're in education, in Mississippi, the law is if your child has an IQ of 130 or higher, that school district has to provide a gifted education program for that child. Well, that 130 wasn't picked out of the air. It came off this picture. So do you see what they're really doing? In Mississippi, they're serving about the top 2.5% of kids a gifted program. So these numbers become really important in the real world. So between 1 deviation below and 1 above is 68% of your data. Within 2 deviations, that means 2 deviations below the mean to 2 deviations above the mean is 95% of the data. Within 3 standard deviations of your mean, so that's 3 below to 3 above, is 99 7/10% of your data. So you need to know that. Okay. Now your homework's going to be on Moodle, so you try it. If you have any questions, then you need to email me. Okay. So your homework is still going to be in the same place that it always is, and it's going to come off of this measures of variation. So you're going to find me the range of data, high, minus, low. You're going to find me the standard deviation of that same list of data. All right. Then you're going to find me the variance for that data. All right. So you're going to do all of that. All right. Then on your next video, I'm going to show you how to do the standard deviation for a table. But I need you to be able to do the standard deviation for a list of numbers first. Okay. Then the standard deviation of a table is just going to be another formula. And that's that the formula table, the formula for the standard deviation of a frequency table is on your formula sheet. Okay. So you go try that homework and let me know, and then I'll see you back in class on Thursday to answer your questions. all right? And at that time, that's when I'm going to show you how to find the standard deviation of the table before I send you to watch another video about standard deviation, like relative standing, measures of relative standing. All right. Hopefully that's keeps it clear up. See you later.